All right, guys, haven't done one in a while, but we're going to dive into what we're calling our basic integrals. Now, we went over the kind of the reverse power rule yesterday. So with integrals, this one, sometimes they call this the most complicated rule. People call it that. We have usubstitution. There's really two different ways. One's like a conceptual way, and one's like the algebraic way, which is usubstitution. Make sure you use your reference sheet for any trig identities or integrals that you need. And really what we're doing is the reverse chain rule. So on the sheet that you guys have, when you look at the examples, I'm gonna kind of go over it by the examples, and then so this will be a little bit longer of a video. I'm going to go over by the examples, and then I'm going to show you the way they show you on the examples, and then I'm going to do a couple of substitutions of the same ones for you, and maybe do side by side. I'm not sure, really quick. Oh, this is dx. So when we take this is really saying that we've taken the derivative already, okay? And we want to work backwards. We're going to go backwards to, excuse me, to our f of x. So if we kind of look at this conceptually, we have this idea that there's an f of x there, but we've already taken the derivative. We've really taken the derivative already, and we got this. So looking at this, you know that this was a parenthesis, so we had to do some sort of a chain rule with it. So to get here, we had to subtract one. So to go back, we have to add one. So our best guess, without doing anything, our best guess is that it's 7x minus 4 to the negative 4. Okay, that's our best guess, because we know that this had to come from taking the derivative of this whole thing, which is going to be subtracting 1. All right, so now, we don't know anything else. We got here somehow, and we're not sure how we got there. So let's just kind of look at it from that point of view. We know that we started with this f of x like this, and our best guess is that we took the derivative of the whole thing, but we're not sure how we got to 28, so we'll leave this box here like that. And 7x to the negative 4th minus 5 to the negative 5th. 7x minus 4 to the negative 5th. There it is right there. Okay? So then, from that point, oops. All right, from that point, actually, I don't want that one there. Actually, we do. We know that we're missing something out front. So from that point, we have to take the derivative of the inside. So we're going to multiply by 7. Derivative of the inside is 7. So now we're looking at this piece here, and we've just taken the derivative. So this is the derivative from our best guess scenario of where it started. And if we set that equal to the other derivative that we know is true, we end up with this. I can solve now for this missing piece. This is the missing link right there. Okay? So if I solve for this, so if I just start looking at stuff, dx divided by dx, they're going to cancel. 7x minus 2 to the negative 5th. 7x minus 2 to the negative 5th. They're going to cancel. Negative 4 times 7 is negative 28. Negative 28 divided by, 28 divided by negative 28 is negative 1. So the box is equal to negative 1. So my negative 1 goes here, plus c. There's my f of x. Okay, so we're looking at it as a conceptual piece. I just kind of work my way backwards, okay? So let's go ahead and look at the next one. I know some of you are just wondering, what the heck just happened? All right, so let's look at our next one on that sheet. Okay, so we've got the integral of x cubed. Whoops. X to the fourth, x to the fourth minus 1, negative 3, right? Oh no, geez, wrong problem. 2. Okay. So, here's our best guess. Let's look at it this way. Where's our best guess that this thing came from? Our best guess is the fact that we used the chain rule of this. So, don't know where this came from yet. Can't work backwards from that because we're missing pieces. So our best guess is that there was something out front and we have this idea that it's x to the fourth minus 1 and it's 1 power higher. Because remember, I would have to subtract off of this. Okay? That's our best guess when we're coming from this f of x. So this is best guess of our f of x. Now, let's take the derivative of the best guess. So, I'm going to take the derivative of this best guess. So, if I take the derivative of this best guess, including this box, I'm going to get 3 times the missing piece, x to the fourth minus 1, subtract my 1 power, and I multiplied out front, and we're going to multiply that by the derivative of the inside, which is 4x cubed. I want you to notice some patterns here. Look, here's my x cubed. That's where it came from. Okay? My 2 came from the fact that I did the derivative using the chain rule property. So now we've got some pieces, and this is dx. Well, we know that this is my best guess f of x. Well, we also know that we have a true derivative and if we can solve for this piece here, dx, x to the fourth squared, x to the fourth minus 1 squared, x to the third. So now I'm left with 1 on this side. 3 times 4 is 12 times the missing piece. That means the missing piece is 1/12. 1/12 goes right here. There is now no longer my best guess. That is my answer. Okay? So, what I really want you guys to notice is when we're taking a derivative of the inside, when I take the derivative of the inside, my whole goal is to get rid of this. If you think about it, it's to divide that out. That disappeared. It's not there anymore. See, I went from here to here. So my whole goal is to get rid of that piece. So let's tackle another one. And we'll process this here. This one will do with our trig functions. 6 cosine, and this is 2 sine t, right? Yeah, 2 sine t to the negative 2. Okay. So this one, 2 sine t to the negative 3. Negative 3 dt. All right, so this one here, look. So if we're looking at this, you've got this parentheses piece here. It's more complicated than this one. It's got a negative 3 there, so somehow I got to this point by taking the derivative of this piece. So our best guess again, for f of x is the fact that I have this parentheses, 2 sine t, okay? And I took the derivative, because I don't know where this came from. Don't know where it came from, so there it is. I took this derivative of this with 1 power higher, so it would be negative 2 right there. That is my best guess. So, if you guys are already seeing it, Well, this is going to cancel out because I'm going to take the derivative of sine of t. The derivative of the sine of t is the cosine. So we're starting to relate some pieces together here. So let's take the derivative of the best guess. So I'll just call it best guess prime, including the missing piece. So we're going to go -2, the missing piece, times 2 sine of t, power rule, times the derivative of the inside, which is going to be 2 cosine of t. Okay? So, best guess, missing the piece where I don't know where it came from. I don't know really where this completely came from. I know where cosine came from, don't know where the 6 came from yet. Take the derivative of our best guess, gives me this. We set that equal to 6 cosine 2 sine t to the -3 dt. We start doing some work here. Our cosines cancel. Our dt's cancel. 2 sine t -3, 2 sine t -3. I'm left with a 6 and a -4. So -4 missing piece equals 6. The missing piece is 6 over -4, which is equal to -3/2. So therefore, my best guess is now -3/2 plus c. Okay? All right, so that's the conceptual piece. You can do these all day long like this. So now what you're going to see as you guys move on is what's called usubstitution. And that's what we kind of worked with before. So let's talk about usubstitution. Let's go back to that original one. And let's do 28, 7x minus 2 squared. -5th, sorry. -5th dx. Okay. So, we're going to look at it this way. We're going to let this equal u. So, let 7x minus 2, actually, do it this way. Let u equal 7x minus 2. That means du equals 7 dx. Okay? So, let's rearrange this. We're going to take this constant, and we can leave it there if you want. I'll just move it out front. It's easier to move them out front. We've got that piece. Because we're trying to figure out, remember, where this came from. And then this is now u. So this becomes u to the -5th. And we still have our dx. Okay, but remember, I need this thing in terms of u. So I can solve for dx, and I get 1/7 du. That means, if I rewrite this, I have 28 times the 1/7 here times the integral of u -5 du now. Okay, because I changed it. So now I can integrate this. This is easy to integrate. You guys have done this before. So if I clean this up, I get I get 4 times 1/4, which will be a negative because I'm going to add 1 and divide. Okay? So then times u to the -4th, and the du is gone, plus c. What's u? U is the original. So 4 times -1/4 is negative times 7x minus 2 to the -4th plus c. Same exact answer we got before. And so this would be f of x. So in the other ones, when we did our best guess, that's kind of what we're doing here. We're cleaning this up and saying, okay, I'm going to change this into terms of u. Once I'm done with u, it's easy to integrate things just with the power. So I kind of take the chain rule out of it, apply the reverse power rule to pieces, and then I plug the chain rule back into it. Let's try another one here. Let's try another one. So, hey, superstar, I'm doing calculus.
You doing videos?
Yeah, I'm doing calculus videos.
Sorry, man. Okay.
No, you're good. Say, hi, Mr. Welch.
Hello!
There you go. All the calculus kids just said, what the heck just happened? All right, guys, let's do this second one here. All right, so I keep writing the wrong, I keep doing that negative. It's just 2, sorry. All right, so we're dealing with this one. Don't forget, this is dx. All right, so we know this had to come from the chain rule somehow. So we're going to say, all right, let's just make it easy on ourselves. We're going to say, all right, let u equal x to the 4th minus 1. That means du equals 4x cubed dx. That means dx is going to equal du 4x cubed. All right. So now we're going to take this idea and apply it over here. So we're going to have our integral of x cubed u squared dx. What's dx now? Dx is du here. So let's clean this up. I can move this out front and make it 1 over 4x cubed du. So this will move to the very front of the problem. So I get x cubed over 4, or let's look at it this way, times 1 times 4x cubed times u squared du. So let's clean all this stuff up. Look at x cubed disappears, x cubed disappears. If you guys remember in the last thing I talked about, our whole goal is to make this thing disappear. Okay? So that disappeared. I'm left with 1/4. So 1/4 comes out. Integrate this. We get u cubed over 3. Du disappears. And it becomes plus c. Clean all this up. 3 times 4. So this is f of x is equal to 1/12 u x to the 4th minus 1 cubed plus c. Same exact idea. Okay? It's called usubstitution. You'll see this a lot more as you guys move on through your mathematics career. Okay? All right, last one. Last one. 6 cosine 2 sine t to the negative 3 dt. Did I get that one right? Yeah. All right. So again, take our more complicated one. Our whole goal is to cancel that cosine out somehow. So again, we're going to go let u equal 2 sine of t. Therefore, du is equal to 2 cosine t dt. That means du is over 2 cosine of t equals dt. Here's my setup. I got to use this stuff, plug it in. So I'm going to take my integral, 6 cosine. I know I've got u, kind of showing you a little different way. Got u to the negative 3. And then at this point, I have dt, which is different, which is du over 2 cosine of t. All right, so remember, this is a multiplication out here. So let's clean all this stuff up, and then we can deal with it. So I'm going to leave the integration sign there for you guys right now. Cosine t, cancel. 6 divided by 2 is 3u, negative 3 to the negative third, times du. So now we've got this piece here. Now I can integrate this. 3 times, add 1, u to the negative 2, divide by negative 2, times, oops, du is gone, plus c. Now, my new f of x, I should say f of t, is going to be 3 divided by negative 2 times u, which is 2 sine of t, to the negative 2 plus c. All right, guys. 3 examples done 2 different ways. Usubstitution. We also have the best guess method. Whichever way you're comfortable with, I'm okay with. I will use the usubstitution a little bit more, but I can explain them either way. Good luck. Have fun. We'll see you soon.